Hey guys, welcome to this course. My name is Biswajit. I'm a multi-vendor network trainer, and here's my introduction for this entire course. I'm a Cisco certified system instructor, plus I'm having multiple firewall certifications as well. Also, I'm certified for VMware, AWS, Aruba, and other vendors as listed over here. I'm having overall 15 plus years of technical experience into IT training and development, and I teach multiple people across the globe. And they are from different sectors. So my domain expertise is basically into routing and switching, which comprises anything with respect to multi-vendors, Cisco, Aruba, Juniper, Comware, etc. I have also expertise with network security technologies, data center technologies, service provider, wireless, SD-WAN, and cloud computing. I hope this course will be very much beneficial for you guys. And I would like to thank everyone for joining to this course. All the best. See you soon.
We'll talk about access list and its implementation on this particular real life scenario. So we have got an inside network, okay, a LAN network. We have some LAN users as 1 dot and 11 dot, okay. That's your perimeter device, R2, which connects your, it can be a firewall, can be a router, let's say anything, okay. It's an edge device, which connects to your outside network. These should be all publics, all right. And we'll talk about access list, how it really implements on inside and outside scenarios, okay. So let's configure them first. All right, I want you guys to help me out for the configuration part. So let's talk about R1. Can you guys help me? How many loopbacks should I create here?
2.
Okay. And next class onwards, make sure that from tomorrow onwards, I will not keep anything, configuration part. It's just for the first day, okay? All the IPs will be pre-configured in my labs. So interface loopback 0. I'm talking about this should be a private IP, but as an example, I've taken 1 here and loopback 1, 11, 11, 11. I don't really like using CLI directly and configuring it. I normally use Notepad, type out my commands, copy there and paste it in the CLI. Okay, you'll experience this when I talk about VPN and ASA a lot. So next on interface F0/0, I'm using 172.16.12.1. That's it. And if I need to run routing protocol so that I want inside and outside everybody to communicate with each other. Generally, you will not run an IGP like that. So I will run EIGRP or OSPF, whatever, just to make sure that my inside and outside networks are reachable. Okay, so everything is reachable to one another. Generally, in the industry, what you'll see is you have BGP between R3 and R4, because ISP towards internet routers, they will all run with BGP. R2 will point a default route towards the ISP to reach anywhere in the internet, and between R1 and R2 might be internally between their sites, they run IGP. Okay, that should be the real life design, but here to make sure that everybody can reach each other, we are going to run some sort of IGP. The fastest one being EIGRP, we'll think about EIGRP here. So let's say if you see here, show IP route and its routing table. You see here 111 and 172 are the connected networks, and we run IGP on the connected networks. So router EIGRP say AS number 10 should match everywhere. No auto summary. Network I'm running for 1 dot. I'm running for 11 dot, and I'm running for 172.16 dot. Good. Any question?
No.
Perfect. Thank you. So on R2, the global config, I have a loopback. I have 2222 F00 172.16.12.2. One thing in my classes, what happens is R1, all the host IPs is .1, R2, all the host IPs are .2, 3, 4. Likewise, all the host IPs on the interfaces is .3. Okay, so today you'll understand this better. So I've taken here 172.16.12.1 on this port. So I'll take 172.16.12.2 on this port connecting R1. Okay. Likewise on R2 F01, I'll keep 150.123.2 because it's R2. I can give any host IP, but I'll keep it as .2 because it is R2. All right. Likewise on 3, I'll keep 3 on the ports, 4 on the ports as a host IPs. So I've done this F0/0, okay, and F0/1. This is 150.1.23.2. All right. And if you see do show IP route, complete routing table, you'll have 150.123, you have 172, and you have 2. So let's run routing protocol over here. Generally, I will not run ERGRP on all the networks, but just for simplicity, I'm running ERGRP everywhere in this design. Network 2 dot, network 150.1 dot, all right, and network 172.16 dot. All right. And there is a neighborship with R1, as you all know, it will come up, exchange the routes. R3. Interface loopback 3 dot 0. This is 150.1.23.3. I hope you understand why I gave .3 there, because it's my host IP. It's R3, so everywhere is .3. 150.1.34.3. All right. Do show IP routing table. Everything is connected, and I can go and run router EIGRP AS10, should be same everywhere, no auto summary, network 3 dot, and network, I think 151 makes sense to everywhere because 151 is part of both the networks, and it will form neighborship with R2. Okay. On R4, last but not the least, we have loopback 4 of 0, 0 that goes towards an ISP. So 150.1.34 dot. What should I give here, guys?
4.
Now, if you agree, I can give anything 1, 2, 3, 4, 5, 6 till 254, but I'm giving here .4 because it's R4. So likewise, the routing table, I have here 4 and 150. Let's run EIGRP across both of them. 4 dot and 150.1.00. It forms neighborship with R4. Okay. Now, if you think about this particular router 4, and everybody will have now EIGRP routes to reach everywhere in this domain. Yes, no?
Yes.
Yes.
So if I say show IP route, EIGRP routes only, okay, I would say everything is known to R4. He knows how to reach 1, 2, 3, 172s, 11, 150, 123. So all the non-directly connected networks are known to him using EIGRP. And likewise, it can reach 1111, okay, from its exit port, and also it can reach 1111 using source of 4444, right? So across everything, your EIGRP networks are up, okay? Just for last verification, likewise on R1, show IP route EIGRP, you have all the routes known to him, and it can reach anywhere. For example, 3333 source of 1111. Anything can reach it. All right, so far so good. Now, any question? All good, guys? So make sure it's a basic CCNA, and I want everybody to quickly run the setup and then start with the configuration. Now, access list, right? Access list is brought forward as a basic form of security on your layer 3 appliances, okay? Without access list, what would happen is you saw that everybody can talk to everybody, isn't it? So once you don't want your outside people to reach inside, or you want to have some policies where inside people cannot reach certain networks or resources on the outside, how do you control them? As a basic security parameter that is brought forward on your layer 3 devices, that is your access control list. Now ACL is of two varieties. You can learn ACL on layer 2 devices and also on layer 3 devices. Okay, so on layer 2 devices, when you implement ACL, so ACL implemented as a layer 2 technology, you can do that for MAC address filtering or for VLAN based filtering. So ACL would understand the MAC address of 48 bits and VLAN ID of how many bits? If MAC address is 48 bits, VLAN ID is of how many bits? Anyone? No one? Okay, it's 12 bits. All right, VLAN ID is of 12 bits. The range is still 4096, right? So it's 12 bits. So anyway, so layer 2 access list can understand MAC and VLAN based IDs. But on the other hand, when you implement access list on a layer 3 based object, like it has to do filtering based on IP address, right? Anything which is top of layer 2. So you have this OSI, that's your layer 1. Then comes your layer 2, right? Then comes your layer 3, layer 4. And you don't discuss a lot of things. I directly say layer 7, okay? Because I don't worry about session and presentation and networking concepts. So you can implement ACL here. So basically MAC access list, VLAN based access list, Ether type ACL, all those things will be called as a layer 2 access list. You can also apply access list on layer 3, that is your IPv4 based access list on L4. But when you apply access list on L4, so basically to filter TCP UDP parameters, right? And also you can apply access list on the protocols which runs on top of network layer, right? Like ICMP, EIGRP, GRE, OSPF, okay? So many more. So these protocols are sitting on top of network layer. So you can run ACL to run some policies for those protocols as well. So basically ACLs can filter your IPv4 plus TCP UDP parameters, okay? And also it can work on application protocols, but not directly, but by filtering TCP UDP port numbers, it can work with your application protocols as well. For example, if you want to filter HTTP traffic, you cannot say access list that directly, I want to filter HTTP traffic. You can work with the port numbers of HTTP on TCP. Let us say port number 80 or port number 443, which implies that this is a parameter of HTTP, right? So basically access lists are used for filtering traffic, which is coming inbound or going outbound from an edge or a perimeter device. Okay, to run access list for a particular job, okay, you do not have to configure access list everywhere on the network. So let us say you have a job where a traffic from X going to Y has to be blocked. To achieve this particular job, it's not required that you go and configure access list everywhere. You might think that, okay, X and Y is known to all the routers, so let's go to all the routers and configure ACL to filter X and Y. Okay, this would be a really wrong approach. So you guys know already from CCNA, CCNP perspective that you need to do for a particular access list, select a router which is based on the routing table. It must know X, it must know Y, and that has to be an edge device. Okay, so generally you configure access list on the edge devices. It can be a firewall, it can be a router, but that is normally an edge device. Okay, so we talk about ACL as a layer 3 implementation here. which will filter your IPv4 and network layer and top of network layer, those protocols, right? On layer 3 ACL, you have different types. Okay, so you have standard ACL. You have basically, I'll talk about like that. So you have two types, right? So let me take the notepad and create some notes for you, and I'll share those notes with you guys. So we talk about access list. I don't like this font. Okay. Access list. Okay. So when we talk about IPv4 access list, we majorly have two types. Can anyone tell me the two types?
Standard and
Standard and extended.
Extended.
Okay.
Number and
Absolutely. We have numbered and
Name.
yeah. Don't worry, it's okay. So you can have a numbered ACL.
1 to 9.
Okay. No, we'll talk about those things. A numbered ACL. Okay, you can create a numbered access list in standard and extended manner, isn't it? Likewise, also you can create a named ACL in the same manner, standard and extended manner. Okay, so we have other varieties of ACL. We'll discuss those things slowly. Hold on. So when you talk about numbered and named, the basic difference is what? On the access control entries, on the ACL statements, the statements are defined by using a number. You call the access control list entries by using a number, or you can call the ACL using a name, right? The basic difference is this. So basically you work with standard ACL. First we begin with standard ACL, right? So what standard ACL does? What it does?
Yeah, it does. Sorry, it just does the IP traffic filtering. You cannot do any port based or
yeah, it will just match the prefix.
yeah.
I'll absolutely.
So it will apply on the near to the destination.
See, application don't bother about it, since you need to learn. This is a real-time scenario. Okay, understand this. If you would have learned like R1 connected to R2, they have a LAN, now ACL and all. Now when we think about this, okay, X is going to Y. I need to apply standard ACL. This is the source. This is my destination. Oh, standard ACL has to be applied closest to the source. That means, oh, apply on R1. Right? If it is extended, which will filter both based on source IP and destination IP, you apply on R2. I'm not talking about those things. Okay? These things are gone in old-fashioned stories. I'm talking about ACLs on real life. So basically, all standard ACL and extended ACL, whatever ACLs you'll create where?
On the edge.
On the
Perfect.
edge.
On the edge. So whatever inside traffic will go outside, or whatever outside traffic would try to come inside, you'll filter them or deny or permit them where? On the edge, right? Now, now the implementation of the ACL could be done on F01 or F00, isn't it? Isn't it?
Yes.
That is your choice. You apply wherever, I don't care. That is your choice. But at the end of the day, you must know that if you apply on here, what should be the disadvantages? If you apply here, what should be the disadvantages? You have to think about those two parameters. Okay? But the concept is you can apply ACL, or you have to apply ACL where? On the edge, only on the edge. So let's say a scenario. Okay? So somebody, see in my organization, okay, let's say these two are my server IP. This is my LAN, 1111, and 11 is my server IP. Okay. Now this is my, let us say, servers, which is hosted in the public. So public can access my server, and my business lies over here. They can say I'm a retailer company. I have my all business websites on this particular server. So let's say anybody on outside can access my server IP, right? So now let's say 4444. This is an outside guy. He can access just for fun 1111. Good. That's my source IP. That's my destination IP. He can access this. And in GNS also, you can see that they can access because we are running with the ERGRP, right? 4 can talk to 1. The point is, 4 is trying to send a lot of packets to 1111 and trying to attack him. Let us say a very simple attack called as a DOS attack, denial of service attack, right? So DOS attack, what happens is normally in DOS, you send so many IP based or TCP based or UDP based packets or segments, so that this particular destination IP, the processing capabilities gets freezed, right? So you do some DOS from 4 to 1. I want to prevent that. But I want to prevent that just by filtering only the source IP of the packet. Good. I want to prevent only by source IP of the packet. So on the edge, what should I do? Create a standard ACL and tell this particular router that, hey, whenever, let us say I applied the ACL on this port, okay? So I've told him that whenever you see that there is an incoming packet on F0/1, if F0/1 is running with an ACL statement, it has to process the ACL statement first before it does routing. So before doing routing, ACL should be processed first. So in the ACL, I would do what? I would deny any IP based packet that is coming from which source? 4444. That's it. So whenever this particular interface receives an incoming IPv4 packet and he sees that the packet is having a source IP of 4444, he denies it. Right? And everything else should be manually permitted, because you know from your previous days that on the second line of ACL you have an implicit deny, right? If you don't manually permit the remaining networks, they will all be implicitly denied. Right? So I'm gonna deny only this particular IP and rest should be allowed. This is my simple job. So let's say I do that. Let's say I do that. Okay. So I create one access list here. So standard ACL, what it does, it filters based on source IP address field of the IPv4 packet and nothing else. Okay. That is the work of standard ACL. It just filters the traffic based only on the source IP address. It looks only that source IP address field, and if it matches with the access list statement, it takes action of either permitting or denying it. Okay. Okay. So I want right now the first lab. The first lab says deny this R4 loopback, which is on the outside, not to send any packets to R1 loopback 0 present on inside. Okay. Perform this task using standard ACL. Anyone else can reach R1 loopback 0 from outside. Is that clear? Ocean.
Yeah.
So I'll be sharing this notepad files, the lab tasks that we do in the classes over email to all of you. So don't worry for that. Okay. Okay, guys. So how do I do that? So basically what I'm saying is deny R4 loopback on outside, not to send any packets to R1 loopback on inside. Perform this task using standard ACL. Anyone else can reach R1 loopback 0 from outside. So basically I'm trying to filter 4444 not to access 1111, but I'm going to filter using standard ACL on this device R2. Okay, so can anyone help me out with the commands? With the commands. So on router R2, right? R2 is my edge here on router R2. What should I do?
Configure an access list denying.
Okay, on R2, what should I do? On the global config mode.
Access list
Mhm.
and then number 1 not
This is standard ACL. So standard ACL will have a number from 1 to 99.
99.
And
So
extended for a number of 100 to 199.
Mhm.
Okay, so let's say 1. Deny.
And
Deny what?
host.
IP.
We can
Now
give
see, I can do two ways. I can do two ways. I can deny the whole network. In that case, let me give like that with the wildcard mask of 0 to 55 with the ACL, right? That means I'm denying the whole network of 4. But since everybody is not doing the DOS attack to me, only one guy is creating problem. So what I'll do is I'll give deny host a particular IP of this. When you do host, no need to give 0000 match all the bits, because in Cisco iOS, what happens is when you give the command host, the implicitly the wildcard mask is 0000. Okay.
yeah.
Next, what do you do?
Access list 1, permit any.
Perfect. If you don't give this command, what happens is
It will deny everything.
deny everything. Implicit deny at the end of the statement. Right. And then what I do?
Then we need to apply it on the interface, in or out.
Perfect. Perfect. So if we apply, make sure you should know the traffic direction, right? Traffic flow. Traffic flow. So if my source is 4444 and my destination going is 1111 and the traffic is coming in this direction, so for this interface the traffic is inbound. For this interface, after routing, the traffic would be outbound. Good. So I want to deny the packet based on this source IP. So what I do is I will apply this ACL exactly on this port, right? So before it could do routing, it could do processing of the routing, it denies, it checks the ACL over here and it denies the packet. That's it. All right. So let me apply the ACL on F0/1 and the direction would be what? Inbound. So, sorry, here. Just a second, guys. Okay. Interface, which one? F0/1, then
In.
access group, but IP access group,
Access.
1, inbound.
Inbound.
If I apply this on F00, this will be outbound, OUT, out. Correct? All of you good with that? Any question?
no.
Yeah, good.
Basic form of ACL. We'll do many more, coming many more. Okay, we'll do that. So what I do is let's configure this, copy that, and apply this on which router? On R2. Good. So now, if you see show access list, what do you find? This is my sequence number. I've got two sequence numbers, starts with 10, increments of 10. So first sequence number of 10 says that deny host this, permit anything. And why there is a 6 matches on this permit any host? And this second statement, why there is a 6 matches? Okay. If you see more, there are 27 matches, right? Counter is running 30 matches. What is that?
Hellos, EHs.
Hello.
Yeah, GRP hello packets.
Right.
Good. Because on F0/1, you say permit any packet. So what happens is it is also incoming or sending what packet? Incoming, right? It is also receiving ERGP hellos from R3. So those are getting permitted. If you don't write this permit any statement, what will happen is you will lose ERGRP neighborship between R2 to R3. Very important, right? Okay, so right now we have achieved this. We also applied the access list on F01, showed on interface F01. You can see this is applied over here. Now to verify, what I'll do is I will go to R1, okay, and enable R1 as a telnet and also as an HTTP server. So first command is IP HTTP server, enable that as an HTTP access resource, and line VTY04, password says Cisco, login, exit, that's all, right? So I have enabled telnet and HTTP services on R1 with the simple commands. Now from R4, what is denied, guys? Which IP is denied? Not to access 1111.
4444.
It's 4444.
So from R4, if I try to ping, let's say ICMP, isn't it? Ping. Ping what? 1111. Will that work if I just ping here from R4?
Yes, this will work.
Yes.
This will work, right? Because now the exit IP is 151.34.4. And that is not blocked anywhere. This will definitely work. Good. What will not work is this with source of this.
Yeah.
Yes.
Perfect. Similarly, if you try to ping, oh, let's say telnet, because everything is blocked, isn't it? Everything is blocked. It's not like specific services from 4 is blocked. It's all services from 4 is denied to reach 1111 or to reach anywhere. So whenever R2 finds the source IP incoming on F01 is 4444, he denies everything. So telnet, what happens here? Telnet what? 1111 / source interface loopback 0. Do you understand what I'm doing? I'm trying to telnet this IP from my loopback 4. Will that be allowed? Will that
No,
be
it
allowed?
should be denied.
Should be.
We denied
Everything
it.
should be denied.
Yeah.
Yes.
But you guys remember how I'm doing it. In similar way, you must practice it. Okay? Destination unreachable, gateway host down. But if I do telnet without the source interface, 2.1, will that work?
Yes.
Yes.
This will work. We're trying open password, Cisco, enter, I'm inside R1. Good. Likewise, how do you test HTTP services enabled on R1? Let's say I try to telnet 1111.
And
Port
you
80.
can take port, yeah.
Source interface loopback 0. This is the way you try to test your HTTP access. Good. That should be denied. But if you access without the loopback, open means HTTP resources are allowed. Good. Very simple. You have denied 4 not to access anybody. Good. Now he's an attacker, right? That 4 is an attacker. He's doing some DOS attacks to my internal resources of my servers, 11, 1. He's trying to send a lot of packets to my server. Good. A lot of packets to my server. I think in this, my Wireshark, it's having some issue. Do you know the meaning of this UUU? I'm trying to ping 1 from 4. I'm getting U because of the ACL on R2, which is blocking 4444. Perfect. But I'm getting U here. What is the meaning of U? That means this attacker 4, when he's trying to access 11 or anybody, any IP, right? And if he gets U, it means that this network exists. This network exists somewhere. So 4 is trying to send a packet. For example, you just see like this. Now, let us say I'm trying to ping a non-existing IP, which is say 19111. What I get here? I get dots.
Okay.
This is request timed out. Good. So an attacker, when he gets some messages like destination host unreachable as UUU, it means what? This IP is existing somewhere on the inside perimeter of the company. Versus, he tries to ping this, he gets what? Dots, request timed out. He doesn't know that this IP exists or doesn't exist, isn't it? It's an ICMP reply saying that the destination IP is unreachable. Clear? Sending an echo,
Yeah, clear. Yes.
echo request and you get an echo reply. The reply says that ICMP unreachable. So, but when you get ICMP unreachables, it means to the attacker, it means that the IP is existing somewhere on the network. Now to stop this, what I do, it's a very simple thing. Look here. I go to the interface. Which interface my ACL is applied and the traffic is incoming?
F01.
F01.
F/1.
Correct. I give this command. What's that? Very, very important command, applied many times in your Cisco OS or on the perimeter devices if you are using ACL on the routers. If you do ACL on the firewalls, not required. Got it? No IP unreachable. So now look to R4 and try to access the same IP. You're getting UUU. Now you get what? Request timed out. It means that the attacker is confused whether this IP exists or doesn't exist. Okay, one simple command. So what is the command? On the port, I gave one command, no IP unreachables. Good. So you talk about standard ACL, it filters traffic based only on what? The source IP of your packet, nothing else. So for example, if you want to deny this IP not to come somewhere, you deny this, only this, using the same statement that I've shown you on this port. Please mute yourself, whoever is unmuted. Okay, I'm getting a lot of background noise. Likewise, just think about it. I've given you one statement, right? I've given you one example of it. So whenever you configure an access list to deny a particular host, you bother about that single IP, you can use standard ACL. But this is very rarely used. Okay, because normally you will go with what? Normally you'll go with extended ACL to filter any traffic condition, because it can do filter of IP based traffic, not only based on source IP, but with many other parameters, right? Many other parameters. So I'll just keep that in the notes. Okay. So to work with extended ACLs, guys, work with your extended ACLs, you need to know operation of OSI model with respect to protocols and port numbers. That's very, very important. And what is the definition of extended ACL? Extended ACL have the capability of filtering traffic based on source IP, destination IP, IP protocol numbers, TCP/UDP port numbers, application protocols, which is pointed by TCP/UDP port numbers. Very, very important term. So by using XNet ACL, you can filter any IP-based traffic based on multiple parameters, right? So when 4444, let us say if he is trying to access 1111, you apply XNet ACL on this interface, what happens is, this is the source, that's the destination. So the ACL will check both the source and destination. And also you can apply the conditions for which type of traffic this is denied. For example, you can define, is it for telnet or is it for, HTTP or HTTPS, different services, FTP, DNS, DHCP, based on the TCP/UDP port numbers, right? And also you can define, protocol number, IP protocol number. So you can filter traffic based on IP protocol number. So do you understand the meaning of IP protocol number, guys? This OSPF protocol number is 88. EIGRP is how much?
89.
89.
ICMP is how much? 1.
1.
TCP is 6. UDP is 17.
17.
Right. What about GRE? Anyone? $47.
Okay, and we have 53 for.
Yes, that's not protocol number, guys. That's
That
port number.
Port
Okay.
Understand? This is TCP/UDP port number versus protocol number. Okay. Just for refresher, what is the meaning of protocol number? This is layer 3, right? This is layer 4. This is layer 7. This is layer 2. And we have a special layer, which is top of network layer. For fun, ICMP lies here. TCP UDP lies on layer 4. And example, HTTP lies on layer 7. And layer 3, we have IP, IPv4, IPv6. Okay. So now, when HTTP traffic, right, is going from application downwards, your TCP source port number is random, say 1234. What's the destination port number for HTTP
80.
traffic? It's 80.
80.
Right. Then what happens after TCP encapsulation is done with your upper layer data? It will encapsulate what? Your layer 3. This is your layer 4. That's your layer 7, isn't it? Your IP header is encapsulated. Your IP header will have source IP. You'll have destination IP. And it will have this protocol number field exactly here.
Right.
Okay. This protocol number field will define that which is the upper layer protocol for which this encapsulation is going on. So now this layer 3 IPv4 header is doing the encapsulation for TCP. Okay. What's the protocol number? 6.
6.
Am I clear? If it is DNS, if DNS traffic goes downwards from layer 7, it is UDP now, right? UDP traffic is encapsulated by whom now? IP, with whatever source and destination IP, and then you'll have this protocol number of 17. Careful. Your ICMP, it does not need any TCP/UDP port numbers, right?
Yes.
Because it does not reside on L7. So ICMP services, when they come out, okay, they go to add directly to L3. Directly to L3. In that case, with whatever source IP and destination IP, but in that case, what is this protocol number?
1.
So now if you apply an access list on layer 3, that means what? You can filter traffic based on TCP UDP port numbers. You can filter traffic based on source IP, destination IP. You can filter traffic based on what? This important field called as protocol number. Good. For example, EIGRP, it also lies here. When EIGRP traffic goes out, what is the protocol number?
89.
88. 88. 89 for OSPF, right? All right. So let's proceed with lab 2 of an extended ACL. So let's say that I have an attacker. An attacker is sitting on outside. It is from R4 loopback interface, is trying to attack R1 loopback 0 for telnet services. Okay, I want to block this attack and ensure at the same time HTTP services are allowed from R4 loop to R1 loop 0. Good. So what I'm trying to do here, get the quotient first, guys, and try to implement this. R2
access list 100 or any number like access list.
IP access list. Extended.
Okay. Access IP access list is a command for named ACL, right?
Yes.
We're doing numbered ACL. We're on the page of numbered ACL. In the numbered ACL, we saw a format of standard numbered ACL. Now we are doing extended numbered ACL, right? We'll do named ACL today. Don't worry. We'll do that. Access list, what?
100.
100.
Okay. I like this number. Okay. I don't know why. 101. Okay. Next.
Deny.
Okay, you can
Deny IP address and the
Deny what?
IP address.
Don't
deny
forget.
the
Deny TCP
telnet
equal to
23.
80.
I am denying, one second guys, I am denying 444 not to access this for doing what? This.
Telnet.
And I'm allowing 444 to access 111 for which service? For 80.
80.
What 80?
Allow. Good. I could have told to allow HTTPS, which will be what? 443.
43.
But I didn't enable on router R1 HTTPS services, doesn't it? I can do that. That's also fine. Going to R1 and I can just tell what? IP HTTP server secure server. Generate RSA bits of 1024 for encryption. HTTPS. Good. So now 443 is also present to be accessed. Anyway, so now tell me, deny what? Denying TCP service.
TCP 23.
Denying the
equal to
TCP
23.
service from host. From host 4444 going to host where? 1
1
1
1 1
1.
1.
what?
Equal to 23.
Perfect.
Any you can write. Okay, yeah, you have mentioned 1 1 1. Okay.
Good. Should not be any because I'm specific to the IPs, isn't it?
Yes, yes, that's true.
My quotient. Okay. Access list 101. I'm permitting. What now?
IP any.
I can write permit IP host from 444 to access 111 EQ 80, but no need. Hope you understand, right?
Yes.
Correct. And next, what I'm doing?
Go to
Apply
the
the
Interface.
interface F01
F01.
IP access
Access group
group 101.
101 in.
Good. Clear, all of you?
Yes.
Perfect. Copy that. Go to the perimeter R2. Paste it. You have one more standard ACL here that denies actually a lot of things. So do show access list. I have this ACL number 1, right? So no access list 1. Do show access list. I have an extended ACL of 101 which denies telnet from 4 to 1. And what? Permits IP NEA. Why this matches? Because of this ERGRP hello package. Okay, how do I test it, guys? From which router? From 4.
From 4.
Telnet 2 1 source.
Loopback 0.
Will that work?
No. 444 is blocked.
As per your statement, look into that. As per your statement, was the first statement. Denying 444 not to access 111 for telnet. This should be blocked. And what should be allowed? HTTP.
What?
Rest of the traffic, yes. HTTP, HTTPS, anything is allowed.
Even if you tell it without the source interface, it should be allowed. Will be allowed.
Absolutely, yes. Come on, break. Control Shift 6X. Oh, yes. Okay. If I telnet, leave telnet. Oh, sorry. If I telnet 1111 to port number 80, source interface, loopback 0, will that be allowed?
Yes.
Open. Good. HTTP is allowed, and also I can allow what? HTTPS, which I've enabled just now. Open. Good. Very simple. This would be lab number 3. Let's say I want to play with now some different IPs. Say this is an outside IP 3 dot. This is inside IP 11 dot. So I want to block or allow HTTP access between those two. So let's say that I want to. So an attacker on outside from R3 loopback is trying to attack, say R1 loopback interface, loopback 1 interface, and exhausting all HTTP services. Okay, so let's block this HTTP attack at the same time ensure other services are allowed from anywhere else. Good. So I'm trying to block what? The HTTP services from R3's loopback, not to access
R1's loopback.
R1 loopback 1. So this is the source, okay, and 1111 is my destination. Source is 3, destination is 11. Can you help me out with the solution here? So on, 1 second. Okay.
Access list.
Access list.
Yeah.
102.
Okay. 101 is already applied. Correct.
HTTP.
Deny.
HTTP.
Deny.
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 Mhm.
HTTP.
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 IP address.
Host.
Host. Yes.
Host.
Deny
TCP.
TCP. Deny TCP, guys.
Yeah.
Deny.
Yes.
Yeah.
TCP host.
Just a twist in the question. Just twist in the question. Just 1 second. 1 second.
Okay.
Little tweak the question. Yeah, nothing else. Tucker. Look back. Network. What I'm doing is I'm not blocking a single host IP. Block this HTTP attack from the network. Means I'm trying to block every IP of 3330/24. So I'm not gonna allow anybody of this network to do HTTP access on 11.11.11.11. Okay, keeping this in mind, tell me the answer. Deny TCP1.
TCP IP address and
IP.
Should I give host here?
Net
No.
marks. No.
no
I
host.
cannot
means
give host.
it is a particular host.
If it
You
is a
can
particular
give-
host, I should define this with the host keyword.
Correct.
Now it has to be this with
0.250.
0.0.255. Yeah.
correct. Going to host where?
11.11.
11.
Perfect. Now not completed. Equivalent what?
Equivalent to
2 port.
port
80.
80.
But
And
But 443 will be allowed, right?
that's
If
fine.
HTTP
As per question is block what resource?
only HTTP.
I didn't discuss about HTTPS. Ensure other services are allowed, right?
Okay.
So in CCI exams and all, you get this kind of, tweaks. All right, 102, what happens?
Permit IP any.
Permit IP any. Apply on F0/1
1.
IP
Access
access
group
group 102.
102 in.
but then we have to remove access group that 101, right? To apply this.
We can run.
Both?
We can run.
No. Two access list on the same interface on the same direction, not allowed, right?
Big thing.
Okay.
Okay. It was a iOS based concept, right? So prior to like 9 dot and all, they're not accepting.
Okay, now it's possible.
How it's possible? Because think about it, in real time, you'll become mad, right?
Right, that's what. So,
This was a actually bad impact on ACL statements. Now everything is fine. Okay, so this is all good. Now 3, anybody of 3 can't access what? Show access list. I have 101, I have 102. Perfect, they are working. Show run interface F01. I have
Okay, it auto removed this 101.
101.
101
Oh,
got removed. Right. 101 got removed and 102 got added to it. This is which version?
Overrides.
This is 12. Oh, from 15 onwards, there is no issue at all. This is 12. This is 12.4. 15 onwards, because have you seen L routes and all? Here you don't see L routes, isn't it?
Here we don't see it, right? In the new iOS, we see
In
the
the new iOS, we can have multiple access groups. No worries. Cool. I'm not bothered about this. I want to check my conditions are working or not. So what should I do now? How do I access it? How do I test it?
from R3.
From R3.
Try to access HTTP service over port number 80.
Telnet to whom?
11.11.11.
1111.
Okay.
Source interface.
No,
Yeah, anything.
Yeah.
okay, yeah.
Yeah. This should not be allowed. It should be
Blocked.
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 Good. It's not happening. What will be allowed?
Other services
You
other than
yeah, you can try HTTPS. Yes, it works.
on port 443.
Yes, should work. Should break. So I'm going to do the same thing, but 443. Open. Okay. So far, so good. You understand the varieties of it. Now, what I've done is I have created separate entries for HTTP and separate entries for Telnet, isn't it? So in one access list, I'm saying deny Telnet services. In another access list, I'm saying what? Deny HTTP services, isn't it, guys?
Yes.
Can't I merge them into one ACL? Say, hey, deny TCP from that for Telnet, deny TCP from that to this for HTTP, and permit rest. Can't I do that?
Yes.
Yes.
I can. Good. So I want to merge now 2 things into one ACL. 2 or more different services into one access list. Okay. Can we do this? Let's do that. So this would be my lab 4. Say block the telnet attack on R1 loop 0 interface from R3 loop 0 interface, and also block HTTP services on R1 loop 1 interface from R4 loop interface. Rest everything are allowed.
So, sir,
Good.
here in R3, so we are
So
just
just a second. Let's remove the previous access list just to create avoid any confusions. Okay. So if I see here, show, I'll come back to you, Deepak, just a second. 101, 102. Let's remove that. No access list 101. No access list 102. Interface F0s. Oh, sorry, that should be removed. To show run interface F0/1. Interface F0/1. No IP. Anyway, it will get overridden. But 102 10. Perfect. Yes, Deepak, tell me.
So, sir, in R3 here, we are just blocking the loopback, not the whole network.
Yeah, correct.
Yeah.
In the last case, we have blocked a network. Just we are trying to see different types. No, where do you use the host keyword? Where you don't use the host keyword?
Yeah, yeah.
So on the perimeter router R2, what should I do? Can you hear me? Murthy, can you hear me? Am I audible?
Yeah, I can hear you. Yeah, I can.
Perfect. Can you answer me?
Yeah,
So I'm
can
on
you
last
repeat?
four, so it's 104. Fine. ACL 104. Next what?
It's a deny.
So I'm blocking telnet attack from R1 loopback 0 interface from R3 loopback 0. So deny what? TCP.
TCP. Host.
Correct.
That particular host 3.3.3.3.
Perfect. Going to host.
Going to host 111.
Correct.
Equivalent to
Block telnet 23.
23. Correct.
And also block ACDP services on R1 loop 1 interface from R4 loop interface. So block ACDP, which is access list, same 104, deny TCP from where?
444.
From host.
From host 4444, going to host R1 loop 1.
11.
11.
Q
80.
80. Don't forget, permit IP NEA. Should I give here permit TCP NEA?
No.
No.
Then all UDP and rest different types of traffic gets denied, right?
Right.
Yeah.
That's the reason we normally give IP NEA. Anything layer 3 on top of layer 3, everything is allowed. Now interface F01 IP access root 104. Let's copy that. Paste it on R2. Do show access hyphen list. Good. Telnet block. HTTP blocked. The matching with ARGRP. How to verify that? How to verify that? So R3 loopback 0 interface cannot telnet R1 loop 0. So go to R3. Telnet 1111 source interface loopback 0. They should be blocked.
Yeah.
Okay, it is blocking, and what should be blocked is 4. No HTTP from 4 to 11. So from 4, I'm saying telnet to 11 with a, sorry, port number is 80. Source interface loopback 0. This should be blocked. But he can do telnet, right?
Yes, he can.
Yes.
Correct. And R3 can do what? HTTP? The reverse.
Yes.
The reverse will work. He can do HTTP and R4 can do telnet. Just remove 80 there. Open. We were inside. Good. So far, we are seeing the basic parameters of standard and extended. So now I'm going to permit all your ICMP traffic, which is from outside to, let's say, R1 loop, sorry, 0 interface. Also, let's say we are going to permit telnet from R3 loop to R1 loop 1 interface. At the same time, ensure EIGRP neighborship. Say it's not affected between, I think we have R2 and R3. Okay. The host and protocol specific while creating the ACL bracket ACE. Okay, so let's understand the question first. So permit all the ICMP traffic from outside to R1 loop interface. So every ICMP is allowed from where? From internet, from outside to R1 loop 0 interface. Okay. Next, permit telnet from R3 loop to R1 loop interface. Okay. At the same time, ensure when you do the ACLs, ensure that the EIGRP neighborship is not affected between R2 and R3. Because you'll apply the ACL here on F01. Okay. The EIGRP neighborship should not go down. Be host and protocol specific while creating the access control list. In bracket, access control entries. Be host and protocol specific. You need to define the host IPs and be protocol specific. So for EIGRP also, you should write the ACL. For ICMP, you should write the ACL for ICMP. You get my point? Generally, do you allow pings from outside to inside? Means outside means internet people. Can they ping your inside resources of your LAN?
No.
Do you allow, or is it allowed by default? It should not be, right?
In general, no.
Absolutely. It should not be. In general, it is not, and nobody is allowed to ping from outside to inside. But here what I'm doing is I'm permitting, let's say, all ICMP traffic from out to R1 loopback 0 interface only. Can anyone help me out? This is a little bit complex because here you should be specific to ICMP ACL and EIGRP. Means I'm telling do not give permit IPNENE, which will permit EIGRP for that statement. I want ACL which says permit EIGRP specifically.
So we have to include the protocol number 88.
89.
Okay,
89
we can define this parameters with the names itself. Okay, so tell me first, how do you permit all ICMP from outside to R1 loop?
No, again with the extended ACL.
Absolutely, it is all extended because you are going to filter what? Protocols.
Yes.
Both number.
So the source would be any and the destination
Yes.
would be a loop.
Correct.
Protocol
Correct.
1.
Let's do this one first. Okay, permit all ICMP traffic from out to R1 loop 0. So access list what? Say 105.
5. Yeah.
Permit.
Here you can directly, sorry.
ICMP.
Here you can directly define ICMP.
And then it should be any.
From anybody to host 1111. Do you understand?
Yes.
So I'm telling that from ICMP echo request, echo reply, everything is allowed from anybody on the outside going to host 1111. But if I really want to do this in real time, I would write this one.
Echo reply for the pings.
Yes. Only echo replies are allowed. Requests are blocked. Do you understand?
Yes.
Can you please differentiate?
Absolutely, I got it. So what happens is when R1, let us say if somebody is trying to reach outside. See, why do I allow outside to reach inside? That is wrong, right? So if inside people has to reach internet, or let us say it has to ping to somebody on the internet, that means echo request will go out from where? To go out from here to there, right? That's your echo request. That's your echo request. Based on the echo request, what do you get back from outside? Echo reply. So what I'm allowing on this interface, the reply would come exactly here, right?
Okay, got it.
I'm allowing the replies to be permitted. Good. So now if you just say, permit ICMP from any going to 1111 on this interface, that means what? Even echo request from outside is getting allowed, which I really don't want in the real-time industries. But just for my sake of the caution, I can do that. But understand this, guys, I'm doing it in multiple ways, teaching you multiple ways. So just for the caution, I'm saying that, okay, nobody is, allow everybody from the internet to reach 1111 using ICMP. Done. Now, second one, permit telnet from R3 loop to R1 loop. Permit telnet from R3 loop to R1 loop 1 interface. Help me out.
Access list 105 permit.
Yes.
TCP.
Yes.
Host.
Yes.
3333.
Yes.
Host 1111
equal
1111. Yeah.
1111 equal to 23.
Correct. Second statement done. Third statement for EIGRP. Because I can write here access list permit IPNEN, isn't it?
Yes.
But in that, I know EIGRP will be allowed. You've seen that on my previous labs. I've done it. But now I want to be specific for EIGRP. I don't want to use this command called as access list 105 permit IPNEN. I don't want to use this command.
So IP protocol number, we can use it here. EIGRP.
Okay. So what you have is, see, you can call ICMP, right? Directly. ICMP is in which layer?
Top of network layer.
Likewise, EIGRP, OSPF, GRE, they are also residing on top of network layer, right? So you can
Yes.
call EIGRP directly, exactly in this place. Good. Now, just a quick recap of your routing switching knowledge. So when you talk about EIGRP neighborship, so this router and this router are exchanging what packets? Hello packets? Bidirectional, right? So what's the source of the hello packet? Now my ACL is applied here. So I should not be worried about my outgoing hellos. I'm bothered about my incoming hellos. So for the incoming hellos, what should be my source IP? This one, which is 150.1.23.3. What's my destination IP of EIGRP hellos?
23.2.
2.
Multicast IP address.
Okay.
224.0010. Good. Sometimes EIGRP also process with a unicast hello message. EIGRP has two types of hello. One is multicast hello and one is unicast hello. In that case, it will be 150.1.23.2. So that means you need to allow these two statements specifically for which protocol? For EIGRP. On which interface? F01 on which direction? Inbound direction. Am I clear? Good? To all of you?
Yeah.
So basically, we have to create two different statements allowing for both the multicast IP and the unicast IP, the same command.
Absolutely. On the same command, two access list. Two access list statements to allow this. Okay? So let's do that. Access hyphen list 105 permit what? Permit what?
EIGRP protocol.
Directly.
Okay.
EIGRP host. You do define protocol number 1 and all here? No, right?
No.
Similarly, we call EIGRP. By default, it understand protocol number is what? 88, 89. It will understand. Host what? From 150.1.
Sorry, 23.3.
Going to where?
2 4.
Yeah, 0.10.
Why I'm giving host for multicast IP? Do you understand?
It might be any host with that address.
No. Multicast IP is always reserved, right? That means all the bits must match as 0000. As a reason, it is host. You're matching all the 32 bits of this multicast address, isn't it?
Yes.
You bother about all the 32 bits. That's the reason you are saying host. Likewise, access list 105 permit EIGRP from host 150.1.233 going to host unicast 151.23.2. Should I give access list IP 105 permit IP any?
Then sir, it will then there is what is the point? Then we need to give deny.
Yeah, we needed to deny.
No. What I'm saying is it required now to give access list 105 permit IP any?
No, as per the question, no.
Yeah, it's not right because my EIGRP will work, my ICMP will be allowed, my TCP from 3 to 11 is allowed for telnet. But what would happen is if R4 wants to ping R1, is it allowed?
R4 to
R4.
R1.
Yes,
R4 to
Yes,
R1.
it
Yes, it is
has to.
allowed.
It has to.
Okay, if R4 has to ping 172 network,
No, it
that
will
will
be
not.
blocked.
if R4 has to ping 172, there is no ACL for that. That is blocked.
Implicitly denied.
Correct? For that, I should say IP. Are you getting my point?
You to
For
restore
any other
the RP traffic.
for any other traffic, I am saying IPNA. Now, what I want to check here is the moment I apply this ACL on F0/1, my ERGRP hello packets must match on this ACL statement. It should not match on this statement. Do you understand?
Yes.
Yes.
My hellos should fall on this one. It should not fall on this one. So interface F01 IP access group 105 in. Done. Copy, going to R2. Oh, sorry. I mistakenly didn't give the word callers permit. Nobody told me also. Okay. Now if you see do show access list, what do I have here? Where my ERGRP getting matched?
I didn't get the statement of permitting any.
Okay, this is because I want to test two things here. Okay, guys, I want to test that if I give here ERGR means permit IP any, what happens? If R4 wants to ping, let us say 11 or 172. Imagine, will that work? No, right?
No,
If
it will
R4
not work.
wants to ping this anything else that is not mentioned in the ACL statement, that will not work. Okay. And one more biggest thing that I want to test is that I actually allowed ERGRP traffic on a specific ERGRP access list right over here. Good. So my matches of my ERGRP hellos should fall on this statement, not on this statement, where you can exactly see that your access list for ERGRP is working fine, isn't it? Look.
Okay, yeah, understood. Yeah, explicitly if you need a statement, then yeah, you can create this, but without creating this EAGRP access list, if I give permit IP any also should be working, right?
That will also work, yes.
Yeah.
So you understanding, right? On the previous lab 1 to 4, I think I gave permit IP any. But now I am specifying ERGRP on a specific statement. Can you do that? Yes, you can do that. You're learning multiple ways. Learning multiple ways. Any question, guys? Very clear? Now show access list. 105 is on with this. Now say, this is my, what ACL, guys? My extended ACL, isn't it?
Numbered extended.
Numbered extended ACL. Let me copy that and let me just bring it up in a notepad and try to explain you what is the meaning of it. What I'm discussing here over is disadvantage of numbered ACL. Let's do that. Okay, so now you see that if I want to add a deny statement, let's say I want to add a deny statement. I forgot while writing my lot of access control list entries, I wanted to add a deny statement in the middle somewhere in the ACL. So let's say my condition was deny this host 4.4.4.4 to reach anyone on inside network. Very simple. Nothing can be much simpler than that. Deny host 4444 not to reach anyone on inside network. What ACL it is actually. Looks like standard, isn't it? But yes, I want to add this deny statement. I want to add this deny statement in the middle. So now, if in this particular access list of 105, if you add the statement, where the statement will actually fall?
At the last, after the permit.
At the last, absolutely, at the last of the ACEs. But before the last, you have the second last statement says what? Permit IP any. So will this deny statement be executed?
No, it will not be executed.
Perfect. So that is the biggest disadvantage. So that means what you should do, what? Copy that in the notepad, somewhere in this particular line, edit it with a new sequence number or a lower sequence number, and then, add the deny statement and then copy it and paste it back on the OS. That is real cumbersome. Okay. To avoid this, we normally go for what?
Named extended ACL.
Named ACLs. Okay. So let's do named ACL examples. Because named ACL allows you editing, which is very easy. And also you can do sequence number of the ACL and resequencing of the ACL IDs, which is very simple. Okay, so which lab it was last we have done? Lab 6. Let's do another. This is lab 7. What I want to do is configure above ACE on R2 using named ACL. So I want to create this everything using what ACL? Named ACL, and add deny statement in the middle. And add deny 444 statement in the middle of ACE. All right, guys, can you help me how to do that? The same thing I want to configure, but using what?
Named ACL.
Named ACL. And also don't forget, I want to deny this host, not to access anybody of my inside network, but this should come somewhere in the middle of the statement. So generally we write deny always at the top, isn't it? Generally.
Right. All the denies at the top.
It's best to keep denies on the top and permit on the bottom. But I want to keep, let us say, this deny somewhere between 10 and 20. Right? Between 10 and 20. That's okay. Any name. Okay. Whenever I write ABC, guys, remember one more thing in my classes. When I write ABC, understand it is any name. It's locally significant and any name. It's not case sensitive. But in access list, yes, names are case sensitive. But on ASA, there is a big condition apply. I'll teach you that. Don't worry. Okay, so IP access list extended ABC as the name. Next what?
Then statement.
Check this. Check the statement, and then accordingly, the same thing I will write here. Permit ICMP. Same thing. Right? Nothing.
And the sequence number would be automatic.
Yeah, it takes automatically, right?
Yeah. So I want to not deny host this, right? After this, right. I told you. So deny what?
Deny host.
Deny what? IP services.
IP. Deny
from host 4444 going to any.
Any.
In the middle, isn't it? Deny all IP services from this host going to any. Next, this. And this. Make sense?
Yeah.
How do you apply it?
No need to have
Yeah,
this
access group.
AGRP multicast.
Oh yeah.
Yeah. But anyways, you have
But
any.
any will allow that, right?
But it
Yeah,
will
if
not
you,
satisfy the previous
Criteria.
question.
Yes.
Follow the question and then do. Okay, next what? If you have to apply on F0/1, what is the command?
IP access group
IP access group.
ABC in
ABC
Now it's a name.
in.
Last time it was number, now it is a name. That's it. Exit. So what I want to do is, I want to remove no access list, what, 105, interface F01. Just say no to this.
no IP.
Done. And I want to write this. Okay. Do show access list ABC. So I have an extended ACL of ABC where I am having the sequence numbers. Okay, looks very similar to extended ACL, number extended ACL, but the biggest thing is what? You can remove or edit any sequence numbers over there. Okay, for example, let's say I want to remove this sequence number 30. I want to remove the sequence number 30, and let's say, okay, I want to remove the sequence number 30. Is it possible without removing the whole access list?
Yes, possible.
Because it's a named ACL, isn't it? In numbered ACL, what was the problem is to remove a single entry or edit a single entry, you should remove the whole ACL. But now you can edit a single statement from the ACL itself. So to do that, what should I do it? For example, IP access list, IP access list ABC, sorry, extended ABC. Next, no 30. What it does, if you see show access list now, do show, it removes what? That line number 30. But now, I told you, right? This line number 30, which is removed, you want to add in the middle of 10 and 20. Can you add that? The statement, which was line number 30 here. 10, 20, 30, this one, right guys? I want to add the statement in the middle of 10 and 20. Between these two statements, can I add it? I removed it. I want to place it in the middle of 10 and 20. How can I do it?
Can I use 15?
Absolutely. Any number between 10 and 20, any number. Say 15. Okay. So to do that, command is IP access list extended what? ABC. Then give the sequence number 15. I copy the statement Paste it here. Done. Okay. Show access list. What do you have here? Without removing the ACL, you are doing now the editing of the ACL statements. Removing 30, placing it between certain lines, it is possible. Now, if your senior engineer, let's say, does this on the firewall or on the routers, they'll very much easily understand that, okay, my ACLs were edited, isn't it? Because they can see these numbers are not in sequence. It's 10, then 15, then 20. So somebody has done some editing. So can you put it back on the order? So I want like first as 10, the second permit should be 20, third is 30, and so on. I want to resequence them back in the default order. Can I do that? I want to keep this statement in the second line itself, but I want to keep this with a sequence number of 20.
20, and the 20 should be 30, like that.
And everything will be getting resequenced. So this will be 10, this will be 20, this will be 30, this will be 40. Sorry, yeah. 10, 20, 30, 40, 50, 60. It will be resequenced. Okay. So I'm keeping this in a separate lab for that one. So hope you understood. Lab 7, you've made a named ACL. Also edit the line 30. To do that, what you have done, IP access list extended ABC, then you have given this command no 30 and came back. That's all, right? To add it back, you said IP access hyphen list extended ABC, and then you told 15, then you edited this 30. So this will be 30, this 15, this, you have done this, correct? So I want to keep this in a new lab. Okay, what I want to do is now, because now you see the problem of ordering. So my stuff is, let's say, resequence the above ACE on R2 so that once verified the ACL entries would appear in sequence manner, sequence number increments of 10, which is the default. Okay, so I want to resequence those numbers in increments of 10, which is the default. To do that, all of you are you with me with the pace? You understood what I'm trying to do now?
Yes.
I'm trying to resequence that. Okay, so I say IP access list. It's again extended ABC. Then, any idea?
15 should be delete that.
It's not like this. It's IP access list. One is resequence. Keep the number as ABC. Listen. So you have a starting sequence number now.
Yeah.
So what is the starting sequence number you want to keep? Is 10. Then what do you have? Steps to increment the sequence number. So first is 10, and what is increment in order?
10.
10. Second is 20, right? It's increment of 10.
10, right.
So 10, first one, second is 20, third is 30, like that. That's all. So for the sequence ABC, so this is my command. Let me put it, let me put it in the notepad. So on router R2.
So the resequencing can be done with the named ACL only.
Absolutely. You cannot do resequencing with any other format.
ACL, that's numbered extended whatever. Okay.
Okay. So this, now when you see show access list, nobody can understand what happened in the middle. Everything looks normal without any hesitation of the sequence orderings. Okay, so these are different types of ACLs, quite a few.
But
And
Biswajit, this command will be there in the running config, is it?
yes, it will be.
So we can come to know, right? This has been used. See, check.
It should be there. It should be there.
If it's
You have the IP access list command, right? So
right, but it's not there. So that is the purpose actually. Resequence should not be there, right?
it is correct.
It's not there,
Absolutely.
no.
It's
Yeah,
not there.
that's
not
what it should. It should be like this only.
Correct. It's not there. Very good. Yeah. Good one. So this is perfect.